Great. Hey, thanks everybody for coming to Data Engineers Luncheon number 11. Today we're going to have Obi Anant from Anant talking about a companion to Apache Spark called MLFlow. Obi is data engineer, data analyst, data scientist, and loves data science and machine learning. So I'm really looking forward to this. And our co-organizer, Akwi, I wanted to thank you. I know you're going to be taking a leave of absence. I'm going to miss you. And so whoever's going to be filling in your shoes has big shoes to fill. So I wanted to give a shout out to Akwi for doing an amazing job in all of last year producing, these virtual events and getting them published. So thanks a lot, Akwi. So great work. Looking forward to having you back when you're done with school. So now we definitely need a co-organizer. Appreciate any help we can get. We are part of a larger community called Data Community DC. People from all different backgrounds. We have a big group of meetups banded together. We're a nonprofit. What do we cover here? We cover anything related to data, creating data, moving data, processing data, applying machine learning, operationalizing data engineering. And normally if this was in person, we would ask people to get up and say hi to people that we don't know. So anybody that wants to just say hi, you don't have to show your face if you don't want. Just mind you that you are, this is being recorded, but yeah, you can say hi. Oh, hey, how are you? You're muted. Let me see if you can unmute yourself. Can somebody unmute Krishna? Oh, there you go.
Hey, hi. This is Krishna. So this is my first, first event in this meetup. So
got it. Great. Thanks.
Nice to meet you all.
Appreciate you coming out. We've got Gautam. Did you want to say hi?
Yeah, hi everyone. I'm in DC and work in big data and stuff.
Great, welcome. And we see there's, hey Will, how are you? We have Ricardo. You want to say hi? And let's see. Hey, I see Denzel.
Hey, how's it going?
Hey, good. Good to see you. We have Lisa, Mike, John, and Ricardo. You guys can just say hi and chime in. Give you all a few seconds, and then we're going to get right into the show. Normally, when we did this in person, because we're a community, we really foster the goal of networking, making sure that you get to see who else is in the community. All right, we didn't have any volunteers there. So group rules, if you have a question, just ask it. Like you can unmute yourself and ask it politely. And this is also an opportunity for you to add to the conversation. So if, let's say, OB is talking about something and you're like, oh, I have used that, or I've seen this article about X, that's more than welcome to just chime in and just bring it to the conversation. All right. Anant is one of the sponsors of this event. I actually work for Anant. We do data engineering around real-time data platforms like Cassandra, Spark, and Kafka. And there's actually a Cassandra lunch that happens every Wednesday if you're interested. DataStax is a proud sponsor. They've been sponsoring Data Wranglers and Cassandra DC for about a couple of years now. So GW has been a great sponsor for the whole Data Community DC, not just for us. They have great venues with auditoriums. We have some local sponsors in Chicago and DC, as well as some organizational members that organizational sponsors that organize, help us organize events in the DC area. Okay. All right. Does anybody have any announcements? Announcements can be you looking for work, you offering a job, your meetup, your hackathon, a conference, any classes that you're teaching. This is a community, so any of your announcements are part of the community. Okay. All right, well, seeing none, I will go ahead and mention that, you know, there are lots of community events on Data Community DC, and there's lots of independent, and you saw those 12 meetups, there's lots of events there you can take a look at. This is weekly. There's a Cassandra lunch that happens on Wednesdays, same time. And then we have some events on our site as well. But with further ado, I'd like to hand it over to our presenter, Obi. Obi, I'm going to stop sharing, and there you go.
All right, thank you. I'll get my screen up in a second. Today, what we will be talking about is MLFlow, specifically MLFlow and Spark. We're going to be doing a brief overview of MLFlow, what it is, what the component parts are, and then we're going to, during the demo section, talk a little bit more about its connection specifically with Apache Spark. As a matter of personal preference, if you have a, sorry, 1 moment, I should get the chat up. If you have questions during the course of the presentation, I would prefer if you would either ask them in the chat or wait until we are at a stopping point in between the presentation demo or after the demo. Either of those is fine. So this presentation is actually a part of a series. It has been going on, well, less time than the Data Engineers Lunch, but this is the first component of it that will be on Data Engineers Lunch. The other components can be found on our YouTube and on Anant.us, our blog.anant.us. And they cover other technologies that can be attached to Apache Spark. We talk about notebooks. We talk about various distributed machine learning frameworks. So like there were people maintaining a distributed version of sklearn and TensorFlow, and those things are there, as well as like data lakes. But this time what we're talking about is MLFlow. So the obvious first question is, what is MLFlow? So it's a Databricks product. You can get Databricks if you have like your Spark instance with them. You can also get a managed MLFlow instance. The way it works is it runs a couple of different services up in servers that perform different tasks to help you with your machine learning lifecycle. Yeah, so it's primarily a tool for helping you with your machine learning, like managing all of the data and the training and things that come in, that come with doing machine learning, which if you are, say, a single data scientist, you could probably do all that yourself. But if you're working in an organization with 10 or 100 data scientists, it's probably a good idea to have some sort of external management, just to make sure that everything stays in order. So it includes things like data preprocessing, training, and deployment. You can actually use some of their inbuilt command lines to get predictions from your models, even though the models are, say, stored in file format inside your MLFlow instance. Includes tools for logging your runs as well as saving your data and your trained models. And it's split broadly into 4 modules: MLFlow tracking, projects, models, and registry. And a lot of these are either directories or like file types that contain some of the default things that you might like be familiar with when doing machine learning. So the MLFlow models, which we'll talk about briefly later, is a file that stores your model that sort of fits on top of other storage styles that you might be familiar with. So if you have an ONNX model, or you have just a pickled Python object. Your MLFlow model file will sit on top of that, and it will contain other like metadata and other information. So we have a couple of terms to define. A run in MLFlow is a single instance of execution of the code for a single machine learning model. So it will train one model. An experiment is a named group of runs. They might have different parameters. You can pass them different parameters in order to do a sort of makeshift parameter grid search and compare performance. But mostly it just keeps all of your runs for that particular model in one place. So starting with the components, MLFlow tracking. It's a section of MLFlow for logging metadata about runs and experiments. You can log parameters. So when you tell your model to run with certain parameters, it will log those, save those with the run, so that if you ever need to go back and check, you can tell what parameters you used when running that model, when training it. You can log run parameters. So some of these will be variously automatic. Um, so code version number, and sort of uses that to do model lineage. As you run newer and newer versions of the same run, the model will be updated with version number each time. Logs your start and end times, source information, including file names, project name, and entry point, which is the command that you're actually using to run your code. It can keep track of metrics like accuracy or mean squared error, that sort of thing. And sometimes you can even get your internal model metrics over time. So as you do like a backpropagation step or something, it will log your loss function across every step. And then it also keeps track of artifacts, which can be output models, process data, images or graphs, that sort of thing. MLFlow projects is for packaging your actual code together. It contains, well, it's a directory that contains the name of the project, entry points, which are a list of commands that can run within the project, which is the same entry points that we talked about with tracking. Just you set them using the project API. Information about the parameters, the environment, the way MLFlow works. Well, the default way that MLFlow works is it uses Conda to set up your Python environments if you're using Python. But there are also things you can do that will cause MLFlow to set up a Docker container in which to run, in which it will run your code with all of the prerequisites that are necessary. You can run your projects, like you can get your MLFlow instance on a server wherever it is to run your projects from Git or from local directories. And you can also submit them to run on Databricks and Kubernetes. In the demo a little bit later, we will be submitting them to a standalone Apache Spark instance. But this is just one that's set up quickly to make sure that we have the Spark side of the information when we're running training PySpark models. So MLFlow models is a format for packaging your machine learning models, useful for integration with downstream tools because MLFlow, like APIs for deployment and things like that, can use those specific type of files. Stores your model in ML model format, which is actually just a YAML file, as well as your various library native formats. So if you have a pickled Python model or an NX model or something, that is stored within the larger ML model format. But ML model also contains time created, the run ID if it's associated with any runs from MLFlow tracking, various signatures. Well, no, it's the signature, which is a sort of JSON format definition of your inputs and outputs. So it'll tell you what their names are and types and things like that. And then also an input example, which is formatted in the same way as the input signature, but contains actual data. And MLFlow models has built-in support for Python and R functions, and then loads of other machine learning frameworks. And then MLflow model registry is, it stores your models, so it dovetails with the MLflow models API, but it also has APIs and a UI for your model lifecycle management. So it registers models from various runs, and then other information that gets put in the registry with those models is once you register them, they have unique names, a version number, stages, which are, yeah, it's down there. Each model can be in staging, production, or archived. And so you can set that for each of the models that you have saved. Lineage, so if you train a model on some data in a run, and then you change some settings and train a new model, it will show that they're related to each other, essentially, as well as some other metadata. So model version goes up by 1 every time a model is registered with the same name. Model stage can be staging, production, or archived. And then you can also add annotations or descriptions in Markdown format. This is data that's specifically added by the user. So those are the 4 main components of MLflow. I'm going to move on to the demo in a little bit. If there are questions, now is a good time for them.
Yeah, I had a quick question. This is Raul. So you mentioned you could run it on Databricks. I would expect that because they made it. But when you said that you could run it on Kubernetes, is that Spark on Kubernetes, or is just the MLflow component running on there, and then it talks to Databricks?
I think it's just the MLflow components running on Kubernetes.
Okay.
And you would have to either connect to Databricks or use Kubernetes to also bring up your Apache Spark and talk to that.
But it can work on open source because it is open source. It can work on Apache Spark or any other Spark variant.
Yes, they have a jar available to integrate your Spark with some of the APIs, but it works with some of them out of the box anyway.
Cool.
So there's some little bit of setup required, but it does work.
Got it. Great. Thanks.
Okay. So I should probably put this in the chat at some point. But at the very least, it'll be available with the blog post and the YouTube video later on. But this is a repository. It basically contains the MLflow examples and an installation of Apache Spark, as well as the custom Spark example that I wrote. So all we have done so far is install MLflow and Conda. It is possible to bypass Conda, but you have to install all your prereqs yourself. So it's a little bit of a trade-off. So we're going to run the MLflow UI. All right, we'll see later on that this tracks runs. I'm gonna need some new terminals in order to bring up Spark. Start our Spark master. Is this missing? Just in the wrong folder. Okay. Databricks has the correct UI on it. And then we start our worker node. Okay, so now we have a Spark cluster with one master and one worker. All right, so MLFlow Quick Start has all their examples in a single directory, but I have added one here. It's just called Spark. And first, we'll just run it, and then we'll look through the code a little bit. All right, so the directory contains 3 files. There's a conda.yaml file, which essentially, most important thing that it's doing is installing all the Python dependencies. And there's conda getting the environment set up, the terminal window. There's the ML project file, which has a name. It tells you where the YAML file for setting up the conda environment is, and then it tells you your entry points, including any parameters that you might be using. Um, so in this case, the only parameter is num trees, because when we look at the code, you'll see that we're using a random forest classifier, which builds a single classifier out of a number of trees and has them essentially vote on a correct answer. So in this case, the default is 10 trees, and the number just has to be an integer. Okay, now our code has just started actually running. And you can see our entry point command is python train.py, because the file is called train.py, with a single argument that is num trees. Okay, so down in the terminal, we can see our random forest classifier model has run with 15 trees, and we've gotten out an accuracy of 96%. What we're actually training on here is, well, the first things we're doing is starting up find Spark with the location of our Spark home, which is not set automatically. So we just give it the correct directory and it finds Spark instance. And then we get our Spark context and our Spark session out of that. First thing that we actually do here is we're taking the iris data set from sklearn because they have it stored inside. And it would actually have been pretty easy to get this from a CSV, but this is pretty much equally easy. What we're doing here is we're taking the data out. It's currently stored, well, inside sklearn, the iris data set is a bunch, which is like a dictionary that contains a bunch of NumPy arrays. So what we're doing is we're getting out the data matrix, the target matrix, and what we're doing, we have to reshape it properly, and then we're concatenating them together into a single list. And then here, there's actually a little bit of a clever thing that we're doing, because Spark SQL types don't play well with NumPy types. But if we use toList, it will convert them all back into standard Python types, which Spark SQL deals a lot better with. So then we parallelize, turn it into an RDD, and then turn that RDD into a data frame and give it column names. If we were to run this again with show uncommented, you'll see that we have our data frame, and it has the four classic, what do you call it? Four classic columns, sepal length, sepal width, petal length, and petal width, as well as a species indicator as the label. We get our vector assembler to turn these four labels into a single features column that contains a list that is 4 items long. We split into training and testing data sets, this time with an 80-20 split. And here we get our argument out of the call, out of the parameters call. And then here we start the tracking run. This may or may not show up properly in the MLFlow UI. Yeah. So that's because we're missing the jar that is not showing up properly. But with MLFlow start run associates all of your coming stuff with a single MLFlow run. We build our random forest classifier, give it the correct columns and the parameters. We train it. We predict on the testing data set. And then we get a multi-classification evaluator to evaluate our performance, comparing those predictions to the actual models in the training set. And we get our accuracy out. And then here we log parameters, number of trees, and accuracy. So if it showed up properly in MLFlow, you would be able to see those. And then we're just making sure it's supposed to save to the proper MLFlow UI. So we can see some of the features that do not work with Spark without the jar, especially like they have mlflow.spark.autolog, well, which does not work. It's still a feature in development. But the sklearn autolog does work, and it logs things like start time, end time, and other things automatically. Why are we not getting our new runs? We're running currently their sklearn elasticnet, which is this particular type of logistic regression with a number of different parameters. Okay, we're not getting things showing up properly in MLFlow tracking. but we can at least look at the example file. So if you look at the example that's already here in MLFlow experiments, you can see it has a single metric parameter with a value of 38. If you go back and look inside the actual run, I'm pretty sure the ML runs directory by default only stores a single run at a time, but that also might just be trouble with MLFlow tracking. But if you see inside of parameters, it's storing that same parameter here. It has a number of values for this single metric inside of the run. And there's a feature that I would have liked to show off, but without tracking, can I do that? But essentially, if you run the same run with a number of different parameters, you can then automatically get any of your logged metrics as a graph in MLFlow tracking. So we could see accuracy versus our alpha score if we had run it at a couple of different values for a logistic regression. And then one last thing that I want to try and show off is that you can actually get MLFlow to give you predictions. This one is not in a proper project, so I need to install all of the dependencies. Anyway, this example is just one that runs a logistic regression. If I run that same thing again. Logistic regression. Oh, it does have all the things, so I should be able to just say MLFlow run. Logistic regression. It's also a process that will probably take a little while. So more time for questions if there are any.
The interface you showed for MLFlow, that's running on, I guess it's running on that Git pod.
Yes.
I wonder where the data is stored for this. Is that like on a CSV file somewhere that you can, because it doesn't have its own database, right?
No. It's all a file system. So I think like we were looking at the MLFlow ML runs directory earlier and finding the same parameter, param138 here, and then inside here, param138. So I think that's just how it's storing. Okay, but moving on to MLFlow models. Serve. Really need an offset off the bottom of the screen to avoid the zoom overlay. Anyway, just just going to replace the run ID here. Oh, I accidentally deleted that. Anyway, port number. Okay. Got our service up. So we're going to open another new terminal. And then if we send a request to the REST API with the data formatted properly, we can get back a prediction 1-0 in this case. So it can actually do a sort of soft deployment of your models for you just through the ML Models API.
Sorry, could you repeat that again? Could you repeat that again? You were saying that it can deploy your model for you.
Yes. So it's doing this. It's not a. Okay. So the essence of having a deployed model is that you send it data and it sends you back results. And so this is using ML Models, the API as part of MLFlow to do that. You send it a request to the particular port that it put the service on, which is 1234. Specifically, you send it to /invocations, the endpoint for receiving data to do predictions on. And then it will return you your results. In this case, the data is 1 - 1, and your results are 1-0.
Got it. Cool.
All right, that is all I have for today. Would welcome a bunch more discussion in Data Engineers Lunch about machine learning. So if there are any questions or any other machine learning related topics that anyone would like to talk about, now is the time.
I have a question. So the data scientists usually like work in a different environment, right? They might use a different MLflow tracking server, and they might use a different model registry. So how do you take the tracking experiment and then move it to the production? So basically, is this like a centralized tracking server that's required for all the workflow, or different tracking servers for different environments?
So I think it runs tracking models, model registry as different services, but it's all set up in a central location.
Okay, so the development of the experimentations are part of like a centralized server, and then the production is going to pick up the model that's saved in that model registry, like in a centralized location, and deploy.
Yes. But it's not necessarily doing all of the training on that particular, on the same location as the MLflow servers are running. So when you trigger MLflow to run on here, it's just basically in this case, the Spark server and the MLflow are on the same machine, but you can send like a command out to for your models to be trained out on the Spark server, and then it will get back your model and save it to the MLflow registry.
Okay, so currently we use Databricks. So Databricks has this managed MLflow, right? So you can run your experiments and then use the MLflow tracking server within the workspace, and also as well as a model registry within the workspace, right? But our data science team work in a different workspace, and the production uses a different workspace. So do you have experience like linking that workflow, like basically the model that was trained in a dev workspace, or the experiment that were run in a dev workspace? Like how do you link, like using Databricks?
Yeah, I'm not sure. That might be a question for Databricks themselves.
Okay.
I mean, technically, the trained model can be serialized, right? And wherever that state is, at least my understanding of Databricks is that everything is ultimately stored on S3, like a bunch of the whole system basically
Yes.
S3. So if you can figure out where it is in the S3, you can copy it from one place to another and essentially have access to it. But Databricks would know the answer to that question. It's a good question though.
Yeah. So yeah, I mean, MLflow, like the workspace has a model used, like you can save within the dev workspace Databricks file system. But again, dev is open to everyone, right? So, but how do we ensure and make them move the model to production? And how do we track the lineage as well, right? So,
Yeah, good questions. Maybe we'll reach out to Databricks and have them do a presentation. Great.
yeah. Yep.
Awesome. Any other questions? If not, just hand it back to me and I'll just show everybody the itinerary and maybe get some thoughts on what next topics we can cover. Let's see.
Feel free.
Thank you. All right. So as we started, mentioned that this is our 11th one. We've talked about a bunch of different topics. So unless there are volunteers that want to talk about a particular topic or technology or a process, we're basically following this data engineer's path, meaning what do they need to know to be a good data engineer? So there's programming skills, there's general scripting, there's different types of databases. That's not an exhaustive list, obviously. Different types of data processing ecosystems, scheduling. We had a talk on Airflow from Will. Clouds, different clouds. How does it make a difference if you're a data engineer? Is there anything we can use natively? Different infrastructure components that can empower data operations and data engineering. And then new stuff comes up all the time. So we're just walking through this itinerary unless there are volunteers. If you're interested in talking about something related to basically the ubiquitous problem of every major business, which is to get their shit together in one place, data-wise, and do stuff with it. You're more than welcome, and you can just drop your email in the chat, and one of the co-organizers will reach out to you and figure out what particular week might be a good week, and we'll just add it to the itinerary. There's a bunch of stuff in the backlog. So, for example, Airtable 2.0, sorry, not Airtable. Why did I put Airtable? Airflow 2.0. Although I think you could use Airtable for data engineering, it wouldn't be optimal for large amounts of data. Command line for data engineering, basically going deeper into set and awk, like a hands-on, to show how you can use command line tools to quickly process information where using Spark might be a bit overkill, or how to set up a developer-friendly environment for event-driven stuff. And actually, I'm just putting here how to set up a developer-friendly machine learning ops environment. That's actually good. That's basically what you were asking about, right, Krishna? How do you make it easy for people to go from one environment to the other?
Yeah.
Cool. All right. Well, if there aren't any other topics or discussion, we will call it a day. Just a reminder that all of these sessions are recorded and put onto YouTube. I'll bring it up right now. And you can get it at youtube.com/AnantCorp. Not just a data engineer's lunch, but the Cassandra lunch stuff is also up here. Thanks everybody for coming, and I'm looking forward to seeing you all next week, same time, same place. Have fun, everybody. Make it a great week. Bye-bye.
Thank you.